solving inequalities. The question asks, cookies are packaged in boxes that measure 18 centimeters by 20 centimeters by 6. A larger box is being designed by increasing the length, width, and height of the smaller box by the same length, which is key. That makes this question simpler than it could be. So that the volume is at least 5,280 centimeters cubed. What is the minimum dimension of the box? So here's our box. We'll give it its dimensions. This one is 20 centimeters. It's not quite to scale. 6 centimeters and 18 centimeters. And they said they are going to increase the dimensions of this box, change the color here, by the same length. So in other words, the height of the box is going to increase. Okay. The length of the box, or actually let's do it this way, the width of the box is going to increase by the same length. And also the, what did I say, height, width, depth, and length. That's what I'm missing. We've gone up, we've gone this way, and we're going to go this way. And this is going to increase. Now they're all increasing by the same length, which means theoretically, let's say we can make our box here. It would look something...
Times 4 by everything.
Yeah, probably looks something like this. This is our potential box. Okay? That's going to be the... Oops. Try to do my best to draw it out here for us. Oh, that should have been green. That's okay. Let's say that this is like the new potential box. So it's, yeah, that wasn't bad. That's quite bigger looking than before.
Isn't it 4 times what it should be?
4 times? No, it just says they're going to increase by the same length. So the increase every single time, is those little green lines I wrote, is going to be x, right? So the height goes up by x, the width goes up by x, and the depth goes up by x. So if we were to create a formula for this, we know that we have a width of 20 centimeters plus x, right? We don't know how much it's increasing, but it's increasing by the same amount. Sorry, I should give us a volume formula first. Because this is volume, volume is historically length times width times height or depth or whatever you want to call it. So let's say the length is 20. We're going to increase that by x times the width. The width is, we'll say 6 plus technically x, and the height is 18 plus technically x. Okay, and on top of that, they said they want it to be boxed by the same length. So what is the volume? That it is at least 5,282. So that means it needs to be equal to or larger than 5,280. And this, all the units are in centimeters, right?
Oh, okay.
So in order to deal with this question, we're going to FOIL all of this out. Then we're going to bring over this amount. And then we're going to do some factoring. So I'll pause and I'll FOIL out the part so that it's a little... Actually, we can just do it. I'll do it quickly here. 20 times 6 is going to give us 120 plus 20x plus 6x squared. Okay, we can condense this to be x squared plus 26x plus 120. And then all of that is still times 18 plus x. Bring down the rest. So then we distribute the 18 plus x to everything. First we'll distribute the 18 to everything within here. So we get 18x squared. I'm going to have to bring up a calculator for that part. 18 by 26, 468, 468x, 18 times 120, 18 times 120, 2,160. 160, and then we got to multiply the x times everything, so that'll be plus x cubed plus 26x squared plus 120x, all greater than or equal to 5,280. And then we just collect our like terms. So I'll put them in order here. X cubed will go by itself. We have 2x squareds. We add them together, we get 44. I think that's right.
Yeah, that's right.
44x squared.
26.
120 plus 460, that's going to give us 588x, and then plus 2,160. And we're going to bring this over. We're going to bring over, so minus 5,280 is greater than and equal to 0. When I bring it over, we have nothing left on the other side. So this will give us some negative values. So x cubed plus 44x squared plus 588x, and then
Here, I'll check.
you got it?
2160-522.
There we
I
go.
messed up.
Negative 3,100.
Didn't even put in the second value.
That's all right. We got it. Okay, so here's our function. It's a cubic function. We're going to need to factor it. So this is the part where you got to find an actual factor and go through that whole very long process. So I'm going to pause this and try to find a factor really quickly. 4 is one of the values. So we're going to take 4 and we'll do some synthetic division. We'll take our coefficients. So 144, 588, and negative 3120. And if I take the positive value, then I have to make sure I subtract as I go through this. Or I could just add my way through. Positive value actually should be adding through. So we bring the 1 down, we have 1. We then multiply by 4. So 1 times 4 is 4. 44 and 4 is 48. We then multiply this by 4. 4 times 48. 4 times 48, 192. 192, we add it together, we get 0, carry the 1, king, carry the 1. 780 times 4, and when we bring that up, 780 times 4 should give us, 780 times 4, yeah, 3,120. So that becomes 0. So our factored form of this will be x minus 4, and the other set of brackets will be x squared plus 48x plus 780 is greater than or equal to 0. So we've got to factor the second part here, and you can just use the quadratic formula to factor that. I guess we can quickly go through that part. Quadratic formula is going to be x is equal to negative b plus or minus the square root. We don't have to use these. Square root of b squared minus 4ac divided by 2a.
Are you in the video right now?
Yeah, I can pause it though. So we get negative 48 plus or minus the root of
What does periodic mean?
repeating waves constantly. Plus 4 times 1 times 780, all divided by 2 times 48, which would be 96, I believe. All over 96. All right, so I'm going to quickly calculate that. Quickly looking at this bracket, we end up with actually a negative root, some value, which means there are no other x-intercepts. So the only x-intercept of this question is our positive 4. So let's take a look at this inequality. That means in a rough sketch that this inequality, remember it was a cubic function and it was positive, so that means it's heading in this direction. At positive 4 is where it crosses that barrier. So anything less than that will be a negative value, and we can't decrease the size of the box, but anything to the right of 4, so x values 4 and above, will be positive. So all of these are possible answers. So we're looking for values of 4 or greater for this question. So what are the minimum dimensions of the box? Well, we take the original dimensions of the box, and we know that the minimum value is 4, and anything greater than 4 will suffice for us. So we had a width of 20, so 20 plus 4 gives us 24. We had a depth of 18, or width of 18, and a depth of 6. We add 4 to each of those because that's our x value that we found, 22 and 10. So your new box is a very rough sketch. It's lagging. I should go to art classes. Would be 24 by 22 by 10 would be the new minimum dimensions. And just to verify, you can multiply these values by each other, and they should give us that exact value we're looking for. So 24 times 10 times 22, 5,280. Anything less than that would be smaller in terms of dimensions, and anything greater will be larger. So that would be our minimum dimensions by increasing everything by the size of, or the length of 4.